Hello again. In this lecture, we'll examine what covariance and correlation are and how to use NumPy's built-in functions to compute them. Let's jump right in. Again, we'll import the package and use the 2D array called matrix A. Okay, we'll begin with calculating covariance. The function we need in order to do that is called cov and requires a single input variable, the dataset. Let's call it and pass matrix A as an input, before we discuss what the output represents. Thus, we write np.cov, and in the parentheses, we add the name of the variable. The output is a 3x3 matrix, which is symmetrical over the main diagonal, that is, the diagonal from top left to bottom right. In other words, the value in the second column of the first row is equal to the value of the first column of the second row. The value of the third column of the first row is equal to the value of the first column of the third row, and so on. All these values represent the covariances between different rows of matrix A. For instance, the values on the first row represent the covariance of the first row with itself, then with the second row, and lastly with the third row. Then in the second row, you have the covariance between the second row of matrix A and all the other ones, and so on. Since the covariance between an element and itself is just the variance, all the elements on the main diagonal represent the variance for that associated row. As you probably know, the covariance between two elements, A and B, is the same as the covariance between the elements B and A. This is precisely the reason for the symmetry we see in the outputs. Since the covariance between two specific arrays is always the same, regardless of which array we input first. Good job! Next up, we want to find the correlation coefficients of the matrix. Since correlation is covariance divided by the product of the standard deviations of each of the two elements, we should once again expect a symmetrical matrix. The function is called corcoef, which is just short for correlation coefficient, and it once again finds the relationships between every two rows of the array. Let's call this function and once again use matrix A as an input. Hence, we write np.corcoef and add the name of the variable in parentheses. As expected, the output is a 3x3 matrix, with parallel values along the main diagonal. However, this time we also have only ones featuring on the main diagonal. That's because the correlation between a value and itself is always 1. Thus, we can be sure the results are correct. Fantastic! After covering covariance and correlation, we're ready to move on to a slightly different statistical function, the histogram. In the next lecture, we'll examine what histograms are and how we can use NumPy to create them. Thanks for watching.